I thought I did, but we'll do it anyways. For problem number 6, what we're asked to do is evaluate the xy values or create a table of values. Now the only thing that's different here is that x and y are both dependent on the values for t. So your textbook gave us a bunch of values for t, like they gave us -3, -2, -1, 0, 1, and 2, and I think they even gave us 3. I'm not going to do every single one, but how do I figure that out? Well, the way that I figure this out is I need to plug in -3 to find x. So to find x, if I say x equals t plus 1, if t equals -3, then I will plug in -3 plus 1. So wherever there was a t, I'm going to plug in -3, right? Well, what's -3 plus 1? -2, right? So my x value is -2. Now I do the same thing with y. If I say y is equal to t squared, then I say -3 squared minus 2 times t, which is -3. That gives me 9 plus 6. So what is my y value? 15. Now what this is now when we go to graph this, graphing this is just like the regular Cartesian coordinate system, right? 2, -15. Now for time's sake, what I'd like to do is I'm gonna let my calculator do all the work. So let me, oh man, I got a bunch of stuff open. Let me fire up the old calculator, the handy dandy calculator. Alright, so what I want to do is my calculator will do all this for me. So let me do it one more time and then we'll let the calculator do the rest. So to figure out what x is when t equals -2, I would say x equals, wherever there was a t, I plug in a -2 now. -2 plus 1 is -1. Now if I do this for y, what I end up with is -2 squared minus 2 times the quantity -2. Again, wherever there was a t, I plugged in a -2. Well, that just gives me +4 plus 4, which is 8. Again, if I were to graph these points on the Cartesian coordinate plane, it'd be -1 comma x, or I'm sorry, -1 comma 8, which is x comma y is what I meant to say. So this is just going to be x comma y, all this stuff. So I'm going to let my calculator do the rest of the work for me. So what I could do is, first thing when I turn on my calculator is I need to make sure that I'm in parametric mode. Your calculator can graph parametric equations. So if I put it in parametric mode, then when I come here and hit y equals, it pulls up x equals y equals. So x equals t, now remember we hit the letter t plus 1, alright, that's the x equation. And let me move this out of the way so I can see what the other one was. T squared minus 2t, alright. Now, if I wanted to finish the table of values, I click on second graph, and here's my table of values. Let's make sure Mr. Adams did his math right. -2 comma 15, that's good. -1, 8. Alright, so when t equals 1, what is my x value? 0. And my y value is 3. So the point 3 comma 0 is on my graph. If I let t equal 0, then I get 1 comma 0, and then the next one I get 2 minus 1, and then 3, 0. Now if I graph all those points, this is what the graph will look like. Okay? Now you might say, Mr. Adams, that looks like a parabola. You're right, it does look like a parabola. It probably is. So now why is it not the whole parabola? Well, I've got to remember that when I go to do my zoom, if I hit window, I could start the t value at anything I want. So if I were to do like -10 for t and a maximum t value of 10, it graphs a little differently. Now I'll get the full parabola. But it didn't ask us to graph it specifically. But it wanted us to first write a table of values, which we have done. And then what was the second part they wanted us to do for that? Part B says find the direct algebraic relationship. Alright, So that looks like a parabola, which should be y equals something x squared something something something. So we start with the parametric equation of t squared minus 2t. And what I need to do is I need to plug some x's in here. Well, the easiest way to do that is to take my x equation and subtract 1 from both sides. And when I do that, I get t is equal to x minus 1. Well, if t is equal to x minus 1, what I could do is I could write in here x minus 1, x minus 1, wherever there's a t, right? So this is the old system of equations substitution thing. Do you see what I did there? Wherever there was a t, I plugged in the value x minus 1. And now I have an equation in terms of y and x, but no longer t's. I got rid of the t's. So the next thing I need to do is just distribute this through and expand it and then simplify. So I got y is equal to x minus 1 squared is actually x squared minus 2x plus 1. And then I need to push this through to the parentheses, so I get negative 2x plus 2. Then I want to go through and combine like terms. This is similar to that. Those are like terms. And then here I have a constant number and another constant. So I'm going to add those up, and I get y is equal to x squared minus 4x plus 3. Does that seem right? I did that kind of quick. I don't know if I made a mistake or not. One way I could double check though, well, first let's look at this. What is the y-intercept? Do you guys know what the y-intercept of this thing is? So this is a parabola. If I had to guess, this is a parabola that has a y-intercept at positive 3. Now because this is a negative 4, then it gets shifted on a parabolic path 4 units to the right. So it should sort of look like this. Okay, so if I just look at it as it's graphed in the parametric equations, this should cross right at 3. Let's see. It does, because when t equals negative 1, notice that my x value is 0 and my y value is 3. Does that make sense? Now, if I really wanted to double check it, what I could do is go into mode, hit function, and then graph, what is it? X squared minus 4x, so I would say x squared minus 4x plus 3, then hit graph. It's the same thing, isn't it? That was part B. Let's see what else they want us to do. For part C, graph the relationship in the XY plane. Well, we already did that. And it looks like this. Okay? Any other questions?